So what do we do if we face an integrand that the terms aren't directly related to each other? By that I mean, if we derive x squared right here, it wouldn't bring us to ln squared of x. And if we perform simple operations for ln squared of x right here, it wouldn't bring us to x squared. So in that situation, we usually use a method called integration by parts. So that's what I did. In integration by parts, you designate one part of the integrand as u and the remaining part as dv. The basic rule here is that if you derive what you designated as u, then it wouldn't make much of an effort to derive it. The same as dv. If we designate a part as dv, then integrating it wouldn't take much more time and effort. So first we derive what we designated as u. So what I designated as u is ln squared of x, because it would actually take time if we integrate it, if we designate it as dv and integrate it, because that would be another indication of integration by parts right here. So to make it easier, I just put it here at u. I designated it as u and it will be derived. So in deriving ln squared of x, it's basically the same form as this right here. So to derive this, we use the power rule. Bring down the exponent and copy what's inside, then derive what's inside. So bring down the exponent, we have 2, copy what's inside, ln x, and if we derive ln of x, then we would get 1 over x dx. So combine this 2 by multiplying it, and we get 2 ln x over x dx. Now the remaining part of the integrand is x squared dx. Now in this case, we just integrate it, and it's easy. We use the power rule for that, by which we add 1 to the exponent of x squared right here. So 2 plus 1 would give us 3, and that would be the same for the denominator. Just copy what you have as your new exponent. So we perform the general equation for integration by parts right here. So u is ln squared of x times x cubed over 3. This is the answer. Minus the integral of v du, which is x cubed over 3 times 2 ln x over x times dx. So that would give us the answer right here. So we can further simplify this by taking out the 2/3 right here, and just dividing x cubed by x. That would be x squared. Then we copy everything else. This would just be copied right here, because that's a part of the general formula for integration by parts, and we wouldn't do anything for that. So once we get this one, we get another integrand that is, we could actually use integration by parts right here. So in this case, we integrate by parts once more. So we designate the u and dv. So we have to be consistent. That's the rule for integration by parts. If we designated ln squared of x as u a while ago, then the ln of x here would be designated as u one more time. So that's what I did. Now perform the basic derivations and integrations for these designated parts, the u and dv, to get du and v, and we use, once again, the integration by parts general formula for that. Now we use uv minus v du, which results to this. Now we multiply this x cubed over 3 to the 1 over x dx, and we get 1/3 x squared dx. Bring out the 1/3, because that is called the constant rule, and constant wouldn't make much of a difference in this case. Then we integrate x squared dx. That would give us x cubed over 3. Now we multiply this negative 1/3 to this, and eventually we'll arrive at this answer right here. X cubed ln x over 3 minus x cubed over 9 plus c. Then we plug that to the first equation here. So it would eventually give us the answer of x cubed ln x over 3 minus 2/3. Then we plug into that the answer that we got in here. Then eventually we'll arrive at the answer that if we multiply 2/3 right here to both these terms right here, then this would be the final answer.